Okay, so we have a sequence that is named unit model if the A1 is smaller than A2, all the way to the A sub K minus 1 is smaller than AK. But now after AK, it is changing direction. So AK plus 1, which is the next term after the K term, is smaller than this. And then at the end, we have AI. So for some values, okay. So meaning that like the term in the middle, like not middle, but one of the terms in between the first and the last term is gonna be the largest, and anything to the left of that is smaller, anything to the right of that is also smaller. So based on that, how many permutation of these 8 digits are gonna form a sequence, okay? So let's kind of see what we can have. Like we know the AK in our case is a term in between like these terms, right? And then this has to be largest number in this list, but it could be anywhere other than the first and the last term. So which means if I look at my list, then the 8 is the largest number I have. So maybe 8 could be the second term or the third or the fifth or the seventh, but not the first or the eighth. So let's think about the case for the 8 as the second term. So if I choose like 1 as the first number, and then the second number is going to be 8. So since this is larger than this is okay, but since this is the largest number in this list, we should change our direction of inequality, and then I should have only one option for the next one, because if I choose other than 7, so I should, let's say I choose 6 after 8, then there is no way place to 7, so which means when you have 8, so the next should be the next largest number you should have, which is going to be 7, and then we are going to get this is 6 and 5 and 4, like 3, 2, and we are done. So, but the problem is like this is not only one thing we can do when the 8 is the second term, because I can choose this number 1 instead of 1. We can choose this is 2. This is like, for example, if I choose like 2 smaller than 8, right? So it is still second term. Then the next term should be 7 still, because if I don't choose 7 after 8, there is no other way like to place the 7 after. So then I'm gonna force to get 7 and 6, and then that will be 5 and 4 and 3. And then we don't have 1, so we should include 1 as well. So this is the only way that we can finish this sequence if I start with 2. Meaning that like if I consider this as my first case, where the 8, which is the largest number, is the second term, then my first term could be 1, could be 2, could be 3, could be anything but 8. So if I choose this is 7, for example, then I will get 7, 8, and then 6, 5, all the way to the 1, which is also possible. So the number of ways to do this one is going to be just 7 ways, or 7 choose 1, because I have 8 digit. If I exclude 8, so there are 7 other numbers. So I do have 7 other digit that I can choose for the first spot, which is going to be 7 choose 1. So you may add like find this, which is going to be just 7, but I'm going to leave it for now. So the second case, maybe the 8 is not the second place, maybe it's in the third case. So if I choose, let's say, for example, 1 is the first number, and then 2 is the next, and then 8 is the third, then I will swap the inequality. So you will get 7 and 6 and 5 and like 4, 3, and we are done. But the problem is, as soon as we determine the first 2, the digit before the 8, the others are actually forced to have only one way to finish it. So which means it doesn't really matter how you end it, because there is no more than one way as soon as you determine the first 2. So meaning that the question is gonna tell you how many ways can I actually choose 1 and 2 out of 8, like 7 digit. Because if I just choose 1 and 2, this is one way, that's the only way. But if I choose 2, 5, for example, like I can do that as well. Let me try another example. Let's say 2 smaller than 5, and that is 8. So if this is the case, there is only one way to finish this one, because I already have 2, 5, and 8. So then I should have 7 for sure as the first number, and the next number has to be 6. but 5 is used already, so that's going to be 4, 3, and 1. So as soon as we know the first two digits, then the others are determined immediately, which is why we don't really care much. So that should be just one way to end it. So the question is going to be same as this guy. So how many ways can I actually finish the first two out of 7? So which is 7 choose 2. So I hope you see a pattern now already. So the third case, if the 8 is the third spot, so I'm going to just start with the simple case where 1, 2, and 3, but it doesn't have to 1, 3, 3. So I could have 8 and 7 and 6 and 5, 4, and 3. So then as soon as you determine these three digits, then the remaining are determined by default. So then you just need to ask how many ways can I choose those 3, which is 7 choose 3. So you can find those values as well. And the next one is going to be 1 smaller than 2, smaller than 3, smaller than 4, and then that is smaller than 8. So that should be 7, 6, and 5, and we are done. So as soon as we determine 1, 2, 3, 4, again, these are the numbers I choose, but it could be any of these like 4 numbers out of the 7 numbers. So which is why that could be done 7 choose 4 ways. Okay, so you can swap those 1, 2, 3, 4 with any of those like 7 digits other than 8. So you will have only one sequence to finish. And the next one would be let's say 1, 2, 3, 4, 5, and then that should be smaller than 8. So it will force 7 and 6, and we will be done. So as soon as we determine 1, 2, 3, 4, 5, which is 5 out of 7. So 7 choose 5 basically. And then the last case is 1 smaller than 2, 3, like 4, 5, 6, 8, and then there is only one number left, which is 7. So there is only 7 choose 6. So like we can kind of find their values, you know, 7 choose 2 is not too bad. So that's going to be like 21, 7 choose 3, 7, 6, 5, 6 and 3 factor will cancel. You got 35. And then this is the same as the 7 choose 3. And then 7 choose 5 is the same as 21. And this is same as 7 choose 1. If you add those, you will actually get 126. But you know, we can like make this a bit faster by using our Pascal triangle. Because if you remember, like 7 choose 1 plus 7 choose 2, 7 choose 3, 7 choose like 4, 7 choose 5, and then 7 choose 6. These are the actual numbers in our Pascal's triangles in the 7 row, right? So if you add the every numbers in that row, you will actually get 2 to the 7th power, but we are missing 7 to the 0, 7 choose 0, and 7 choose 7, which is just the 1 at the beginning and 1 at the end. So that means this is equal to 2 to the 7 minus 2, which is also 126, which is also a quick check as well for our other sum. Okay, so I hope that was clear. So that was a, I guess, nice sequence problem by kind of combining with the Pascal's triangle. I'll see you in the next video.